In the second unit p-n junction, we derived ideal diode current equation in which we assumed Shockley ideal diode approximation, as per which there is no recombination taking place in the transition region. But interestingly, light emitting diode operates only because of non-ideal behavior of the transition region, meaning that recombination which is taking place in the transition region is responsible for operation of light emitting diode as well as laser. There are mainly three types of recombination. One is radiative, second is non-radiative, and the third is Shockley-Reed-Hall recombination. We will not be discussing much about Shockley-Reed-Hall recombination, but it occurs because of crystal defects in the semiconductor and the impurity which lies in semiconductor. If the semiconductor crystal is absolutely pure without having any crystal defect, then the possibility of Shockley-Reed-Hall recombination is zero. Now we talk about the other two recombination. You have also studied direct bandgap semiconductors and indirect bandgap semiconductors. Now assume that if we have a transition region which consists of indirect bandgap semiconductors, then rather than emitting a photon will be released, which is a quasi-particle representing a quanta of vibrational or sound energy, which ultimately heats up the device. This type of recombination is referred as non-radiative recombination, and this type of recombination is not desirable for the operation of light emitting diode. The other type of semiconductor which we studied was direct bandgap semiconductors. Assume that the semiconductor material which we have taken for the p-n junction is direct bandgap semiconductor material. Then when a recombination takes place, it will be accompanied by a release of a photon. This is referred as radiative recombination, and this radiative recombination is all what we need for the operation of light emitting diode. This particular process of recombination taking place in the transition region which results in luminescence is referred as injection electroluminescence. Since here diode is emitting light, therefore it is referred as light emitting diode. Two other terms which you are going to study is coherent and monochromatic. Suppose that there is a beam of light. If all the rays of light have the same wavelength, then it will be considered monochromatic. However, coherent requires same wavelength as well as same phase. Light emitting diode is non-coherent device, as the emission which takes place here is spontaneous emission. Spontaneous emission means that the recombination takes place at different points of time, which results in wide angular distribution. If we talk about monochromatic behavior, then also light emitting diode is not highly monochromatic, as there is a small range of wavelength in which the wavelength of light emitting out of the diode varies. So, light emitting diode is both non-monochromatic as well as non-coherent.